Hi, good morning, Prof. This is our group project. We are from Group 1. My name is EVIRIA FREDERICK. Metric number is AF1900024. So today I'm going to present Chapter 1, Company Profile of our project. Company profile consists of 5 subtopics, which are company background, company overview, mission, vision, and organization chart. So this is our company background. Mel's Consultant is a civil engineer firm located in Batu Pahat, Johor. This is our company overview, company registration number, date of incorporation, company address, and the contact email, website, also the CIDB and PKK. This is our mission. This is our company vision. And this is our organization chart. So project director is Melvern, and the project manager is me, EVIRIA, and the architecture is Sarah, and designer is HUSNINA. Thank you. That's all from me. Have a good day, Prof.
I'm Sarah SAUSURRIAWONG, anak perempuan UDOM AF190049. I'm going to present Chapter 2 Project Background. The objective of the project were as follows: to design an adequate foundation of the building, to justify the type of foundation that will be applied to the project, to determine suitable way to enhance the soil are necessary before or during the construction of the foundation, to justify the design specifications, the setting of the site project, and the bearing capacity. The site location is at SMK Senawang, Taman Merida 70450 Senawang, Negeri Sembilan.
Moving on to Chapter 3 for soil analysis, our group is designing a pile length of 7.5 meter where it sits on a stiff layer, and this is the soil profile where the water table can be found at 0.57 meter beneath the ground surface.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Sini Binti Marzi. My metric number is EF190128. I'm from Group 1. So for today, I will explain about analysis and design foundation. So before planning the foundation for the proposed project, the load will be exposed and the allowable load for each column in the building must be estimated. The applied load for each column is determined by the detailed plan for the column, which include in the appendix. The outcome was then taken from the estimate. This project taken into account 34 column analysis from a one-story building, and then the column will be separated into group based on its load. So this table will show each load for the column, and then for the column grouping, each column will be arranged by group according to their load range, and then every group of the column will be designed based on the maximum column loading. For example, group 1, we have the maximum column loading, which is 99.4 kilonewton. From group 2, we have 199.2 kilonewton. Group 3, we have 294.9 kilonewton. Group 4, 358.7 kilonewton. Group 5, 448.4 kilonewton. And then for the last group, which 564.9 kilonewton. So each group will be designed according to the maximum column loading for each group.
Next, I'll present for Chapter 5, Design of Foundation. The ultimate load carrying capacity is the summation of load carrying capacity of the pile point QP plus with the frictional resistance QS. QP can be calculated by taking the average of Meyerhoff's method and Vesik's method, while QS can be calculated by taking the average of alpha, lambda, and beta method. Next, for settlement, we will design using Paulos and Davis method, and this is the formula. And here the table shows the summary of pile dimension and settlement, and all the settlement indicates allowable settlement, which is less than 25 millimeter.
Next, for soil improvement with admixture or inclusion, we have fibroflotation. Fibroflotation is a ground improvement technique used at a considerable depth by using a power electrical or hydraulic probe, which will strain the soil. This technique is used to improve the bearing capacity and reduce the possibility of differential settlement that might allow for the proposed load. So in order to deeply compress the soil and reinforce it so that it can hold the anticipated imposed load, a probe known as the vibrofloat will be used. So the process for vibroflation is really simple. The depth probe is located over the compaction point. So the flushing water or air is expelled through the jet in the tip of the probe. So this induced injet vibration will liquidate the soil temporarily, allowing the probe continuous penetration under its own weight. There are three types of vibration method which we can apply, which are vibro compaction, and then second one we have vibro replacement, which is a wet top feed, and then the last one is vibro replacement dry method. So for next one, we have a dynamic compaction. Dynamic compaction is a soil improvement technology that use a drop weight to densify soil and then fill the material. It is a method that used to increase the density of the soil when the certain subsurface constraint make other method inappropriate. This process involves dropping a heavy weight repeatedly on the ground at regularly spaced interval, and then the weight and the height determine the amount of compaction that will occur. And then the most soil type can be improved using this method, where oil field and the granular soil are most often treated. And then the next one, we have a soil improvement using stabilization with chemical additive. Soil stabilization involves the use of stabilizing agent by the material in the weak soil to improve the geotechnical properties such as crossability, strength, permeability, and durability. This soil improvement by using chemical stabilization will use some chemical additives such as cement, lime, fly ash, and then the blast furnace slag. First one, we have a cement. It may consider a primary stabilizing agent or hydraulic binder because it can be used alone to bring about the stabilizing action required. And then the second one, we have lime. Lime modification describe an increase in strength brought by cation exchange capacity rather than symmetric effect brought by the plosonic reaction.
Chapter 7 Conclusion. In conclusion, the soil property and types obtained from the bore log are appropriate for designing both shallow and deep foundation. For our project, we use a circular pile as the deep foundation. We use Meyerhof method and Vesic method to determine the load carrying capacity of the pile point QP, whereas for the frictional resistance, skin friction derived from the soil pile interface QS was determined using the alpha method, lambda method, and the beta method. The total settlement for each group of loads is less than 25 mm, which is adequate.